So let's solve for x 1.1, x plus 3 multiplied by x minus 1 is equal to 0 for 2 marks. So guys, when you come across this question, please smile because this is a very easy 2 marks. You just equate each of these terms to 0. So you're going to say x plus 3 is equal to 0 or x minus 1 is equal to 0. And then you're just done, you just solve for x. So x is equal to negative 3, x is equal to positive 1. Easy. So let's solve for x. 2 exponent 3x minus 1 is equal to 64 for 3 marks. Now when looking at the left hand side, it's in its simplest form, okay? And 64 is not in its prime base. So let's leave this as it is. 2 exponent 3x minus 1, okay, is equal to, the reason why we're changing 64 is because we're trying to have the same bases so we can then solve the exponents. Whenever you're dealing with exponents, you should always try to check if all numbers are in their prime bases. So in order to write 64 in its prime base, it's basically 2 exponent 6. You can use this using a calculator, so you have to press 64 on the calculator and then press the equal sign, and then you press shift, and then you're going to see a button which has a dot and 3 commas or fact. So you press that, you're going to get 2 exponent 6, which makes things significantly easier for us. Now since the bases are the same, we can now equate these exponents. So it's going to be 3x minus 1 is equal to 6. 3x is equal to 6 plus 1. 3x is equal to 7. And then x is equal to 7 divided by 3. So you're done. Okay, so let's now solve for x for 4 marks, 1.3. 27 exponent x minus 2 is equal to 81 exponent 2x plus 1. Again, we're dealing with exponents. You check if they're in the prime bases. 27 in its prime base is 3 exponent 3. And then all of that is raised to the power x minus 2 is equal to 81 in its prime base is 3 exponent 4. All of that is raised to the power 2x plus 1. Okay? And then from there, you're going to multiply the exponents. So it's 3 exponent 3 times x is 3x. Okay? 3 times negative 2, that is negative 6, is equal to 3 exponent 4 times 2x, that is 8x. 4 times positive 1, that is positive 4. Luckily, the bases are the same now, so it's going to be easy for us to solve this. The bases are the same, we can then equate the exponents. So 3x minus 6 is equal to 8x plus 4. Negative 6 minus 4, we took this positive 4 to this side. Let's take this 3x to this side, so it's going to be 8x minus 3x. So negative 6 minus 4, that is negative 10. This is going to be positive 5x. Divide by 5 on both sides. Negative 2 is equal to x. And then you are done. Not that difficult. So together, let's solve the inequality for 4 marks. Negative 2 is less than 4 plus 2x is less than or equals to 6 and represents solution in the interval notation. So we have negative 2 is less than 4 plus 2x is less than or equals to 6. Let's first take positive 4 across both sides. Negative 2 minus 4 is less than 2x is less than or equals to 6 minus 4. And then negative 2 minus 4, that is negative 6 is less than 2x is less than or equal to 6 minus 4, that is 2. Okay? And then from here, let's divide every thing by 2. So divide by 2, divide by 2, divide by 2. Negative 3 is less than x is less than or equals to positive 1. But now remember, we are asked to represent the solution in interval notation. So you're then going to say x is an element of a circle brackets or the normal brackets negative 3 and the square brackets 1. So I'll tell you what both of these brackets actually mean. This bracket, it means it does not include that particular value. And then in this one, since it's less than or equals to, the equals to includes the positive 1. This one excludes. So you say x is an element of negative 3 and 1. So that's why these brackets are not the same. So let's solve for x and y for 5 marks. X plus 3y minus 5 is equal to 0. 2x minus 6y plus 2 is equal to 0. And when looking at these two, equation 1 looks a bit simpler. So let's just make equation 3 from this one. Let's let x be the subject of the equation or formula. Okay, so it's going to be x is equal to negative 5 is going to be positive 5. 3y is going to be negative 3y. So this is equation 3. And then from here, you're going to substitute equation 3 into equation 2. What does this mean? It means wherever you see an x in equation 2, you're going to substitute 5 minus 3y. So it's 2 multiplied by x is 5 minus 3y. So 5 minus 3y minus 6y plus 2 is equal to 0. 2 times 5, that is positive 10. 2 times negative 3y, that is negative 6y. Minus 6y plus 2 is equal to 0. 10 minus 12y plus 2 is equal to 0. 10 plus 2, that is 12. Minus 12y is equal to 0. 12 is equal to negative 12y across the equal sign is going to be positive 12y. Divide by 12 on both sides. 1 is equal to y. We can then from here solve for x. Let's substitute 1 back to equation 3. So x is equal to 5 minus 3. Our y is positive 1. X is equal to 5. 3 times 1 is 3. 5 minus 3, that is positive 2. So we have solved for x and y. It says here the difference between two numbers is 5. 6 times the smaller number is equal to 4 times the greater number. Find the numbers for 4 marks. So we can see that this is basically a word problem. So let's break it down step by step. The first sentence says the difference between two numbers is 5. So let's write that down. Because remember, difference is subtraction. Between two numbers is equal to 5. Simple as that. The difference between two numbers is 5. And then they said 6 times the smaller number is equal to 4 times the greater number. So you can see that x is the smaller number because it's on this side of the subtraction sign. Okay, so it says 6 times the smaller number is equal to 4 times the greater number. So we can see that this is actually two equations and we can solve them simultaneously. So let's now solve for x and y. So let's make y the subject of the formula. So this is equation 1, this is equation 2. Now let's create equation 3. So it's going to be y is equal to 5, negative x is going to change to positive x. So this is equation 3. And then from here you substitute equation 3 into equation 2. Which means wherever you see a y in equation 2, you're going to substitute 5 plus x. So 6x is equal to 4 multiplied by 5 plus x. Okay, 6x is equal to 4 times 5, that is 20. 4 times x, that is positive 4x. Let's take this 4x across the equal sign, so it's 6x minus 4x is equal to 20. 6x minus 4x, that is 2x, is equal to 20. Divide by 2 on both sides. X is equal to 10. So we've solved for x, let us now solve for y. So we had y is equal to 5 plus x. We can then say y is equal to 5 plus, so remember x is 10, plus 10. So y is equal to 5 plus 10, that is 15. So this is the value of x and this is the value of y. Done. So if p is equal to 1 plus 3 exponent x and q is equal to 1 plus 3 exponent negative x, we're required to prove that q is equal to p divided by p minus 1 for 3 marks. So we're told that q is equal to 1 plus 3 exponent negative x. Okay, and then we're told that p is 1 plus 3 exponent x. Divide all of that by 1 plus 3 exponent x, because it's p again, and then minus 1. Simple as that. Now let's take this side first. So 1 plus 3 exponent negative x. This 1 plus 3 exponent negative x is the same as saying 1 plus 1 divided by 3 exponent x. Why am I saying this is the same? In this scenario, we have a negative exponent. And when you have a negative exponent, when you're returning it back to a positive, you're taking it back to the denominator. Okay? This was positive. When you make it a negative, it goes to the numerator. Okay? If it was negative over here, when you take it to the numerator, it was going to be positive. Okay, let me explain that again. It was negative, changed to positive when you return it to the denominator. Okay? Now the common denominator here is 3 exponent x. So you're going to multiply 1 with 3 exponent x, okay, plus this 1 over here. You won't multiply with anything because it has this common denominator of 3 exponent x. 3 exponent x times 1 is 3 exponent x, and then plus 1, all of that divided by 3 exponent x. Now let's see what's happening on the right hand side, okay? So on the right hand side, we have 1 plus 3 exponent x, all of that divided by 1 plus 3 exponent x minus 1. Now in the denominator, we have 1 and then minus 1. These two can cancel each other out, so we're going to be left with 1 plus 3 exponent x, all of that divided by 3 exponent x. Now these two are exactly the same, it's just that on the numerator, this 3 exponent x is on the left, and then there's positive 1 on this side, there's 1 on the left, and 3 exponent x on the right. So you can basically rewrite this, but this is exactly the same, so you can then say 1 plus 3 exponent x, all of that divided by 3 exponent x is the same as that. So you have shown that q is equal to p over p minus 1 when given these values.